Now I'm going to show you how to extract a value from a max binary heap. Okay, here is a diagram based off how our current structure looks like right now over here. So as I mentioned earlier, is we pre-filled this values array with some initial values, all this right here, and what all these values do is it builds out this tree for us. Okay, now so now what we want to do is we want the ability to be able to extract the value. Now the topmost node over here is going to be the first one to be extracted, because remember, this thing works off a queue, off like a queue methodology, right? Which is first come first serve, or so. Like in this case, this right here, you can also see in this example here, it has an array, and you see that the 100 is the first one in the array, and that is the top level. So the idea is that when we create an extract method, the idea is that it's going to extract or remove this first top node from the very get-go, from the very beginning. So once it removes that, what's going to happen is that it's then going to go to the very last element in the tree structure, which would be this 7. And if you can see in this array, it's 7. And the reason why we know that is because remember that max binary heaps, it goes orderly from top to bottom and going from left to right. So if we go down this level by level, we get to this at the lowest level, but then we got to go from left to right. And so you see this is the furthest element to the right. So this would be considered the last one. And therefore, so again, this will be removed initially, and the second phase is this last element would be popped off from the array. So the 7 will be removed from the array, and then it's gonna be replaced here at the 7. So just imagine that right now, that if we had some animation that this was popped off, and then this 7 was popped off from the end of this, disconnected from the 17, and then instead and replaces the position where this 100 was. So now this 100 is there's a 7 here. Okay, so from this point on, now that there's a 7 here, what happens is we're gonna perform a phase that's called bubbling down. Now bubbling down is what's gonna happen is that it's gonna now that 7 here, there's gonna be a 7 here. It's going to look at both its left and right child, and it's gonna compare and see which is the highest child value. Well, because 36 is the highest value, what's gonna happen is 7, which would be here, is gonna compare 36 and say, is the value 7 less than 36? 7, and that would be true. So in that case, we're going to perform a swap in which the 7 will now be placed here and the 36 will be placed here. So they're going to switch positions. So now the 7 would be here and 36 here. So now again, so we're going to it's going to loop again, and the positions and the elements are going to update. And now that the 7 is here, it's going to do the same thing. It's going to look at both its children here and see which is the highest value of the children. It's going to see 25. So now 7, which is currently now here, is going to say, is 7 less than 25? Well, indeed it is. So in that case, the same thing. We're going to perform a swap. So now 7 is going to be here and 25 would be here. And at that point, well, it will loop again and repeat the whole same process. And then eventually, well, because this is at the very end, there's nothing more to do a comparison. And at that point, the tree is the positioning is now the 7 is positioned exactly where it needs to be. Okay, and that is essentially what we're going to perform in code. Okay, so let's go ahead here to our pseudocode. All right, so the first things first, let's see here. Let me go ahead and reposition this here. All right, so first things first is what I'm going to do is underneath this let me do this here. All right, so I'm going to call this method extract. Extract doesn't take any arguments. Well, the indentation is kind of long here. Okay, there we go. Better. All right, so now we set up our the name of our method, extract, and first things first is we're going to remove the first element. Okay, so removing the first element, because remember what I said, the first step in this thing is popping off or removing this 100, which, by the way, is going to be the value we're going to return at the end. Okay, so let's go ahead and extract that first value. So I'm going to call it first element, and I'm going to do this dot values. All right, values this right here. We're going to remove this element right here. So this values and then the index of 0. That will remove that first element, and we might as well just return that here at the so we don't forget, because remember the idea is that we're gonna extract that element, the first element from there, and then return it, and then but after but in between all that stuff, before we return it, we're going to have to, kind of readjust everything in where it's correct order. And that's where the bubbling phase occurs. So anyways, for now, I'm just going to comment this out, return, and we're going to do some code in between this. All right, so now that we have the first element, let's see, remove last element. Remove the last element, then add it to the end of values array. Again, remember at the second step was, after we remove this right here, is we're going to take the last element in the array, which is 7, and then position it here at the very top. So the way we're going to do that here is, let's see here. All right, so we're going to do last element. I'm going to do this dot values dot unshift. Oh no, pop. Dot pop. So pop is a built-in method for JavaScript that removes the last element. Okay, and it stores it inside this variable here. Let's see here. Yes. So we're going to remove it, last element, and bring it to the very beginning. Yes. Okay. So now what we want to do is this dot values dot unshift last element. All right, so let me just test. Let's just make sure that this is working here. I'm gonna do a console. What I'm gonna do is I'm gonna do a console log. No console log here. All I'm gonna do is save that. We're gonna run this code, and what I'm gonna do is I'm gonna check the heap. So currently the heap initially, actually 7. Let's see here, 7 of this. Yeah, okay, so initially this is the initial setup, and then if we call the extract method on it, so I'm going to do extract, and then this 7, which is the very end, it should be placed here at the very beginning. So if I check now values, okay, that's good. This values, let's see, this values return first element. Let me see something. Store pop. This values first element. Actually, you know what? I made a mistake here. For this first element, we need to not just get a reference, we actually need to remove it from the values array. So what I have to do is I have to call unshift, all right? Because realistically, this should end up with 8 elements inside the array. So let me redo this again. I'm gonna run the code again. So we see that the heap's value is like this initially. I'm gonna call the extract. See the values. Okay. 7. This value's on shift. This value's on shift. Let me see here. Okay. Or is it shift? I think instead of unshift, it's actually supposed to be shift. Sometimes those could be confusing, unshift and shift. It can trip me up sometimes. Let me run this again. So we got the values, call extract, check the values again. All right, there we go. All right. All right, so I got confused between the unshift and shift. All right, so shift would actually remove the first element for the array, whereas unshift actually adds to the beginning of the array. All right, so that could get confusing sometimes. All right, so now that we removed the first element, all right, we removed it because you see that 100 was initially there, and then 100's now gone. And you also see it's one less element inside the array. But in addition to that is you see that, remember over here, these last two lines is we removed the last element, which would be 7, and then we added that 7 to the beginning of the array, which now that I think about it, now that I realize unshift was actually used over here. So that's actually, yeah, unshift was we're adding to the beginning of the array here. All right, so now that's taken care of. All right. All right, so next step, let's see here. So remove the last element, then add to end of values array, set index for the current element. All right, so now that we have all that taken care of, so if we look at this diagram, I want to show you where we're at. So initially, first step, we remove this, pop this off. Then second step was we remove this 7 from this 17, or disconnected from the 17, and replaced it right here, put it to the top. So the next third step is now to start the bubbling phase. So now it's gonna start the comparison and figure out which direction to go and start swapping. All right, so that's where we're at right now. All right, and what I'm gonna do is to clean up the code, make it cleaner, is and we're gonna call this method called bubble down. All right, so bubble down, just like this. All right, and we're gonna call it right below the extract method. So bubble down, just like that. All right, and so let's start right here. All right, so set index for the current element. So we need a starting point. Like initially, we're going to start doing the traversal, or the bubbling down. We're going to start off over here at the very top, right? And that's where we're going to start bubbling down at. So, so set index for the current elements. So, okay, right here. So we're going to do current element. I'm going to set the index for it first, and set that at 0. All right, because remember the top uppermost, or because we're also dealing with a max heap, is it's going to start at the max heap, or the topmost node will be located at as the first element in an array, right? So that would be index 0. But let's go ahead and get the element as well. And the way we're going to get that element is we're going to do this dot values, and then pass in the current index right in there. Okay, so now we have a reference to the current index and the actual current element, which is the topmost node. All right, next step is set current. Yeah, that was what we took care of. So we did the index for the current element and actually set the current element. Next step is to start a loop. And within that loop, and we're going to be doing a while loop, we're going to set the index for the left child and set the index for the right child. Okay, so we're going to do while true and then enter this loop. Now, as I said here, is inside the loop, we're going to set the index for the left child and set index for the right child. So remember that I said in the third phase is, so now that the 7, which is going to be right here now, is going to compare the left child, which is 19, and the right child, 36. So we're going to need to get a reference to both of these individual nodes, the left child and right child. And let's see here. Oh, why is this doing that? All right, I don't like that it's in doing those long indents. Or let me try this again. Why is it doing that? All right. You know what? We're just gonna have to make it happen like this. All right. So now let's get a reference to the left child. All right. So let left child index. Left child index is, this is the portion where we're gonna have to use a formula. Remember that I said that when we're trying to locate, if we have a parent node and we're trying to locate the left, either the left child or the right child of the parent, is we use a formula, right? If let me see here. All right, so let's see the formula. Max binary max heap formula. All right, let me see if I can find it here. Yeah. All right. Yeah. So we can use this here. Okay. All right. So for the left child, it will be located at 2. Well, this one's different. This one says 2 times the index for the left child, and for the right child will be 2 times the index plus 1. But they have this is going to be a little different. Don't worry about this, because the way they have the placement of the index is going to be different from ours. Don't worry about this, but just know that here, this is the formula that we're going to be using. So to find the left child is going to be 2 times the index of the parent element, which currently it's at 0. So, but we're going to do 2 times the current element index, and then plus 1. That's for the left child. Okay. Now for the right child, it's going to be exactly the same, except we're adding 2. Okay. So it's going to be plus 2. And that's to find the right child index. Okay. All right. So now that we have this, we can actually target the actual elements. So we have the index for both the left child, but let's go ahead and actually grab those elements that are located there. So I'm going to do left child element, and then it's going to be this dot is going to be located at this dot values, and then left child index, and the same will be for the right child element here, but we just changed the name just like so. Let me also go back here to the pseudocode. So where we're at is we set the index for the left child. Okay, so we set both the index for the left and right child, and now we're set the left child element and we're setting the right child element. So that's where we're currently at right here, and actually we just finished it here. All right, so that's what these 2 lines of code is. It's completing these 2 here. So next step is set the index of greatest child element. Okay, now remember, let's go back to no, this is the diagram. All right, so this is the diagram we're actually working with based off the data in our array. All right, so remember that I said the third step is we're comparing, right? So, but the thing is that we have to figure out which of the two elements is greater in value. So in this diagram, you see it's gonna be 36, all right? So the way we're gonna figure out which of these two are the greatest value is we're gonna use this. We're gonna create this block of code here. So what I'm gonna call this variable is I'm gonna call it greatest child index. And we're going to do a ternary logical statement here. What we're going to do is I'm going to check to see if the left child element is if the left child element is greater than the right child element, then we're going to have the left child's index be stored as the greatest child index. So if the left child element is greater than the right child, then we're going to make the left child index become the greater child index. Otherwise, we're going to make the right child index be the greatest child index. All right. So next step is we're going to have to set the greatest child element. So we're going to do greatest, not greater child, greatest child element, greater child element, greater child index. Yeah, let's do greatest child index, greater child. Yeah, greater child index. Okay, so greater child element here. And that's going to be this. That's going to be this dot values and then pass in the index for the greater child index right in there. All right, so next step is we're going to do a conditional check. We're going to check if the current element is less than the greatest child element. So remember over here, so what we're going to do is essentially the 7 is going to, now that we know that the greatest child is here, which is going to be the right child, we're going to check is the current value, which in this case, remember that the 7 will be here. Is it less than 36? If it is less than 36, we're going to start swapping. So let's see. So if the current element is less than the greatest child element. All right, so that's what we're doing here now. So I'm going to check if the current element is less than the greater child element, then that means we're gonna start performing some swapping. All right, so that's where we're gonna start swapping the positions of both elements. So the way we're gonna do that is first we're gonna do this values current element index will now be the greater child element, and this dot values greater child index will be the current element, just like this. Let me remove this to be consistent. Let me remove these colons. Okay, so now these two lines of code is we pretty much just swapped out. So the 7, which would have been here, and the 36, well, Now we did the official swap. So now the 7, which was here, will be here, and the 36 would be here. So we swap positions. So next step is to now we have to set the index of the current element to be the index, set index of current element to be the index of the greatest child element. All right, so now we have to start updating these values here, which was like the starting point for our bubbling down phase. So let's go ahead and update. The current element index will now be the greater child index, and our current element will now be this dot values and then current element index, which is here. All right, perfect. Okay, so now where we're at. So all right, so we set the we did this. We set the index of the current element to be the index of the greatest child element, and we also update the current element. So we also did this. Now this is an if-else block condition. So if current element is less than the greatest child, then that means we're gonna have to continue the whole process of swapping now. Now if this condition is not met, if it's falsy, then that means we reach the else block, meaning that, well, the current element will not be less than that would mean that, like, for example, that we reach the exact location, or the element is now that the 7, remember that the 7 was what we started off over here, and then the purpose of the bubbling down was to position it back to where exactly it's supposed to be. So at some point, that once this 7 is not, once it's not less than any of the children, then that means it's exactly in the position within this diagram that it's supposed to be, which if we had this animation going, well, the 7 would end up being here, which would be its final destination, and there wouldn't be any further need to do any more bubbling down, because it's where it's supposed to be and it's at the end. Okay, so that's where this else block comes in, and what we're gonna do is we're gonna call a break. So this break is important too, because we're inside a while loop, and it's running while true, but this break is what's actually gonna break us out of the loop. And if we didn't have this break, well, you know, we're gonna run into that infinite loop. So that's very important to have that break there, and that's pretty much it right there. And then obviously at the end, we're gonna return the first element, because that was the purpose of extracting, performing this extract method, is that it follows a queue, or the queue methodology, right? Or like the first in, first out. And since the topmost node in this is right here, well, we're extracting it, we're removing it from this whole thing, this whole tree structure, and returning it. And that's actually what we're gonna do here inside this extract method after this bubble down method runs, and we're gonna uncomment this here, and it's gonna return the first element. And you saw that we initially did this as the first line of code, is we removed that first element. All right, so now at the very end, after the whole bubbling down phase and we reach the end, is we're actually returning that first element. So that's it for our extract method. Let's go ahead and test this thing out. So let's see. All right, so let's go ahead and run this code, and we're gonna check our values. So remember this right here, which is because we hard coded everything here, is it draws out this diagram here. So what's gonna happen is that, as I mentioned, is that this 100 is gonna be removed, and then this 7 is going to now be removed, popped off or removed from the 17, and then brought back to the 7, and then it's going to bubble down, and then because it's less, it's going to find the less which of the child nodes is less or greater in value, which is 36. So then 7 is going to say, is 7 less than 36? It is. So 7 and 36 are going to swap. So 7 is going to be here, and then it's going to loop again, and then 7 is going to compare with the greatest child, which is here. So it's going to say, is 7 less than 25? It is. So now 7 is going to be here, and then the 25 would be here. So this would be the ending. So 7 would end up being here. So it would end up being the child of 25, right? Because 25 would end up here, and then 7 would be here. So let's go ahead and test this out. Let's go ahead and first test this out. Okay, so running this code. So the value is here. I'm going to call extract. And as I mentioned, that 100 is popped off or removed from our diagram here. But now let's go ahead and see the new updated array, or our values array here. Well, remember we start off with 9 elements in the array. Now we have 8. You see here the 100's missing, and we see that initially 7 was here, and remember I said it's going to be popped off and placed in the beginning over here, and that's what it does. But here you don't see it here because it performs a bubbling phase. So that once during the bubbling phase, eventually what happened is that it ended up here, because this would be considered its correct position. And the way we could test this out and make sure that the 7 is in its correct position is we can actually use that formula that we were using earlier. And let's go ahead and first look at this diagram. So remember what I said is that the 25 would end up here and 7 would be here. So we can determine if that if 25 is here. Let's go ahead and look at the array. Okay, so in this array, we see 25 is here, which is at index, let's see, 0, 1, and 2. So 25 is at index 2. So we can find out what its left child is of 25, right? That's what we're trying to determine here. The left child of 25, which if it's here, what is the left child of 25? It would which would be 7 here, right? So we can find the left child of it by using formula, which is, remember, to determine the left child, the formula for the left child, it would be here. Look at this here. It's 2 times, or it would be 2 times the index, or 2 times the index, 2 times the index, and then plus 1. That determines the left child. So if we do 2 times, what is the index of 25? So 0, 1, 2. So 2 times 2 is 4, right? 4, and then plus 1, so that would be 5, right? All right, so if we look here now in the array, what's at index 5? Let's see, 0, 1, 2, 3, 4, 5. At index 5 is 7, and as I said, the left child should be, the 7 should be the left child of 25, which, looking here at the diagram, well, unfortunately we don't have the animation, but I was trying to explain. So 25 would end up here, and 7 would be here. So the left child of 25 would be 7, okay? All right, and that's it. So we confirmed that the bubbling, that our extraction method for a max heap has worked.